Okay, so they gave you this diagram. Obviously, everything is blue and green. I added into it. Look at that now. We'll go through it step by step. But they're saying in the diagram, A, B, C, and E are the vertices of a parallelogram. So they're not actually saying that it's a parallelogram. They're just saying it's a quadrilateral. AE is parallel to BC. Right? This looks familiar. It seems like we didn't see this. This was on class from yesterday. We spoke through this across. Okay. So those two lines are parallel. So guys, it looks like a parallelogram, but you can't say that yet. Okay, in order to say that something is a parallelogram, you either have to have that both pairs of opposite sides are parallel, or both pairs of opposite sides are equal, or there are two others, we did them last year. One pair of opposite sides parallel and equal, right? That's the third one, or both pairs of opposite angles are equal. I'll give you a summary on that at some point, all right? The different ways to prove that something is a parallelogram. They're just giving some other information stuff that was given on the picture. They're saying M, which is x2, is a point on the EC. We can see that there. Now guys, this is what I'm talking about. The first couple of questions are always easy marks. Okay, so for 3.1, calculate the gradient of these. How easy is that, right? Gradient formula. Change in y over change in x. They gave us the coordinates of b and the coordinates of c. We just need to know that formula and be able to apply. Okay, so there we have the answer to that one. The gradient of BC. You take the y value of the one minus the y value of the other over the x value of the one minus the x value of the other. Right? If you swap your x and y's around, so if you do change in x over change in y, you get 0. So it's very important. Always change in y or change in x. Okay, so the answer there is a half. How many marks was this? 3 marks. That's quite a lot of marks, okay? I'm guessing, sure, it would probably be 2 marks for subbing in, I suppose. All right, in the trick, it's normally a 2 markers. 1 mark for subbing and 1 mark for marks. Okay, but that's something that we can all do, and then we can get the marks for easily. Now, 3.2 is a midpoint question, but it was asked in a different way. They didn't ask you to just calculate the midpoint. They gave you the midpoint, right? They're telling you that M, which is this point here, M, is the midpoint of BC. Right? Now, if we're looking at M, they've given us the y value of M, but not the x value. Okay, but we have the x value of the other two. Right? So we can easily calculate what x is. We're going to say that one plus that one divided by 2. Right? So we're working with the midpoint formula. Remember, to get the x value of the midpoint, you add the two x values together, you divide by 2. All right? Then we have the y value of the midpoint and the y value of that point, but not the y value of that point that's there. So that's the more difficult one to do. So you didn't have to write it out exactly like I did, but I just wrote that M is the midpoint of BC. All right, so there I did the midpoint calculation. X value of the one plus the x value of the other one over 2. Right? To get your y value, you'll take y value of the one, which was y, minus, plus y value of the other one, which is -2, and that will also divide by 2. Okay, so I'm just applying the midpoint formula in that first step. That's all I'm doing. Applying the midpoint formula to E and C. Okay? And then in my next step, I actually put in what the midpoint is. They're telling us that M is the midpoint, right? X2. And I just calculated that 6 plus 4 is 10. Okay, that's all I did. And guys, 10 divided by 2 is 5. Right? So if X is supposed to be 10 over 2, right? This value here is supposed to be that value. Right? X value of the midpoint is supposed to be the two x values added together and divided by 2. So that is where x equals 5 comes from. Okay, are we okay with that? The other one is a bit more difficult. We know that this y value here is supposed to be that value over there. Right, the y value of the midpoint is supposed to be the y value for one point plus the y value of the other point divided by 2. Okay. So now this is actually like an equation that we have to solve. That's a bit more complicated. So now we're going to say, that's what I wrote there, that y minus 2 over 2 is equal to that y value. Okay, those are the two circled plots that I'm making equal to each other. And from there, guys, to get the value of y, you need to move everything across. So this 2, you're going to have to multiply that 2 by, right, to get rid of it. So 2 times 2 is 4. And now this minus 2, you're going to have to add to the other side. That's where y equals 6. Okay, so this is not just a straightforward midpoint formula question, but if you know the midpoint formula, you can figure it out. Okay, you are able to do it. Now, this is also quite a common grade 11 type question. So they have given you the midpoint and you maybe need to find one of the other values. So instead of just finding the midpoint. This was also a 3-mark question. So they usually give a mark for actually like writing some kind of working for showing that you're making the point m equal to those values. And then you'll get a mark for your x value and a mark for your y value. Okay, it does seem a bit strange that this question is getting the same amount of marks as the first question. Okay, it's not really evenly spread, but. And these questions are from departmental grade 11 papers. Some schools write like an external paper at the end of grade 11. So this is what this is. So this kind of stuff is similar to what you can expect in the week. Okay, 3.3 was again a very straightforward question. Calculate the length of BC. You can see I called it in there after I calculated it. But BC, we have the coordinates of B, we have the coordinates of C, and just the distance formula. So there you go. I sub my values in, and I worked it out, and I got root 80. Okay? Did it come up as anything? Could it come up as something else? 4 root 5, yes. Now, to me, it was a bit strange. You can obviously write 4 root 5 here. That is perfect. It is correct. I left it at root 80 because in the information, they told me that another side was for root 80. I'll show you guys now. So here at the top, they said, oh, in 3.4, sorry. If it is further given that AE is equal to root 80, right, which is the same value as that, but root 80 is also just 4 root 5. So, yeah, it's a bit strange to me that they didn't give that in simplified terms. If you have to recognize that they were equal. But okay, are we fine with the distance formula, guys? Just BC, the length of that line. Use the distance formula, you sub it in, you type it into the calculator. You didn't even have to show this step, right? You could have just gone straight from that line, type that straight into the calculator and get your root 80. That was 2 marks, guys. 1 for subbing in, 1 for the answer. Again, easy 2 marks. All right, in this question so far, there are 5 marks that were just straightforward subbing into formula. The gradient of that is 3 marks, and the distance of is 2. Now, this is what I was talking about earlier, guys, where they're now asking us what type of quadrilateral is this, okay, and why. You always have to put a reason for that. Now, it's good for you if you practice. So I don't know if you actually read through this diagram, right? It was obviously on the classroom, so you weren't able to write on it like I did. But if you get this diagram in a test or exam, which you will, please fill stuff in on it. I have said that before, but just again, it is very important. So here, the y value here, for example, I didn't fill that in, but you could have filled in that value of 6, and this x value is 5. All right, so whenever you're working something out, just put it on your picture. BC we calculated was root 80, which is also 4 root 5. Now in 3.4, guys, they're telling us that AE is also root 80. Okay, that's what they're telling us in the question. If it is further given that AE is the square root of 80, to which group of special quadrilaterals does ABCE belong? Even that wording is a bit strange. They're actually just asking what type of quadrilateral it is. Now guys, if we're looking at this, that pair outside is equal, right? Because we got root 80, they're telling us that this is root 80. Right? So those two are equal. And they told us already that those two are also parallel. I don't know if you remember this, but that is one way of proving that something is a parallelogram. You have one pair of opposite sides that are both parallel and equal. Okay. So just write that down, please. That is the reason there. 3.4. ABCE is a parallelogram. And the reason is one pair of opposite sides can be parallel and equal. Okay, so that's not a reason that is used very often. So I'm not sure if you remember that. Now 3.5 is a bit more complicated. We should look at the question. Let's say, determine the equation of AD. Right? They're not telling us what kind of line AD is. They're just saying determine the equation of AD. Now let's take a look at AD, guys. There's point A. We have the coordinates of A. D is over there. Do we have the coordinates of D? But they tell us what D is. No. They are showing us, if I just zoom in, that AD is perpendicular to BC. All right? That is what they're showing us. Now, guys, if we're looking at this triangle, triangle ABC, the whole triangle, right? That's bottom one. And then we are looking at AD. We see that AD is coming from a vertex of that triangle, and it's perpendicular to the opposite side. We call that an altitude, right? Remember, we worked with those three lines. We have a median, which is from one vertex to the midpoint of the opposite side. We have an altitude, which is from one vertex perpendicular to the opposite side. And then you have a perpendicular bisector, which is a combination of the two. So guys, in this question, they're not saying find the equation of the altitude, but you have to look at the picture and see that that is what it is. So that was a bit more difficult. And then you would have had to look back at your notes to see what are the steps when you find the equation of an altitude. You need to find the gradient of BC and then use that to find the gradient of AD. And then southern point A. Right, those are the steps. So you can copy that down quickly if you want to. That is the answer there. 3.5 AD is an altitude from A. It's perpendicular to BC. So what you have to do is you first find the gradient of BC, then you use this perpendicular line thing, right? Remember that the product of the gradient is -1. You use that. You put in your gradient of BC, and that thing allows you to calculate the gradient of AD. And then from there, you need to start at point A. You can't start at point D because we don't have those coordinates. Okay, so the only point that you can sub in here is point A, and then you will end up with that equation. I'll give you guys some time to copy that down because we are going to do 3.6 and 3.7 together. It's important that we do those. Those were like the difficult questions. Okay, so please make sure that you're copying down 3.5. I'll give you some time. Now for 3.6, I actually just want you to see the picture without my scribbling over it. Okay, so that is the original picture. We just calculated AD, right? So AD, this line, is y equals negative 2x minus 2. Okay? Now in 3.6, they're asking us for that one. So what's the order of the B? That's the question. Now guys, the thing that I also wanted to remember is that in the, especially analytical geometry question, usually, and I have said this before, but it is important to use the answer from the previous question in the next one. So that's always a hint. Okay, if you don't know what to do, just think, what did I calculate now? And what was it, 3.5? I found this equation. So can't I use this equation somehow to now find the order of B? You don't have an idea? You don't have an answer, but it's maybe something that you can notice. B is a point on AB, right? Do we agree with that? B is obviously a point on AB. Does B lie on another line as well? On BC? Yes, do we see that? So guys, D is actually a point of intersection of AB and BC, right? It's where those two lines meet, where they cross. How do you find the point of intersection of two lines? So that is to find the gradient. We did it last time when we were working with circles. We found the point of intersection of the circle and the line. Okay. But that's finding a point of intersection and straight line. I think was really for the note here earlier today. Find the point of intersection of two graphs. Let's see what line. Yes, you do simultaneous equations. Right? But guys, in order to do simultaneous equations, the equations of the two lines that point is on. Now we have the equation of AB, because we calculate the equation of BC anyway. Just look through the equations that we've marked now in question 3. Have we actually calculated the equation of BC? No. We just find the gradient of B, right? We found that in the first question. The gradient of B2 and a half. Okay, so we already are kind of halfway there to actually knowing what the equation of B is. If we know that the gradient of B is a half, then we can say y minus y1 is equal to a half x minus x1. And we find the equation of B, which point must I have? Point on BC. How many points do I have on BC? I have 2. Right, so you can choose. I need to start with B, or you can start with C. It's up to you. All right, both of those points lie on that line. Okay, so this is going to be either one or C. Right, so I'll start in 4 negative 2, so I'm going to be below now. So you say y minus this negative 2. What's the minus? That's a plus, right? So it's going to be y plus 2 equals a half x minus this x value, x minus 3. Okay, now we must multiply those numbers up. So we have y plus 2 here. That's going to be a half x minus 2. Right? And then this plus 2 we must also minus. So we alternate in that with a half x minus 2. This is a 3, a half x minus 2, and then this plus 2 is going to come out. Okay, so that's BC. But AB is negative 2x minus 2, and BC is a half x minus 4. Now we need to solve this simultaneously. Alright? What is the first step when you bring simultaneously? Isolate one of the variables. Now guys, if we look at these two equations, we already have that in both of them, right? Both of them already have y isolated. So now we can choose. If we have this negative 2x minus 2 is equal to 1. Now I can put that in the place of y on the left. Right? So we're going to have negative 2x minus 2 equals a half x minus 4. Then we solve x. We use that to solve for y. Okay, I'm going to show you the fully like written out answer. I'm going to talk through that quickly. Well, this is like a problem solving kind of question, guys, because you have to first find the equation and then use the equation to find the actual answer. So it is a difficult one. All right, so I wrote there. These are the point of intersection of A, B, and BC. All right, we discussed that. So therefore, we need to find the equation of BC. And then I just wrote down the two coordinates of B and C. You didn't have to, it was on the picture. The gradient of BC, we found that in 3.1 already. Then, like I did on the board there at the bottom, sub endpoint C, and we got that equation. For point of intersection, I put pure line in there. You need to solve simultaneously. So I just rewrote the two equations that we have. That's the equation of AB. That is BC. And then I did that whole highlighting thing that we did back when we did simultaneous equations for the first time, right? So I'm highlighting that y is equal to this. Now I'm putting that expression in the place of y in the other equation. And then I'm solving for it. Then you use that value for x. I'll zoom in a bit now because it's quite small. I also actually just want to check if that's correct because I did it all in my head. I didn't have a calculator. I just want to make sure negative 14 over 3. Okay, so we know that once you then find your x value, you need to sub that back into your first equation, right, where you isolated the variable in the place of x. You then put your 4 over 3. You work that out, and that is then your y value. Okay, and those two values, the x value and the y value together, that will give you those are the coordinates of point. Okay, sorry, I'm not sure where you guys are now. That. And guys, that's how the analytical geometry questions always go. The first few are quite accessible, quite easy ones, and then you need to use your answers from the first couple of ones to do more difficult questions. Down with it. So yeah, I just wrote the coordinates of D in like mixed numbers because it's a bit more easy to understand, but you didn't have to. You could have left it just 4 over 3 and negative 14 over 3. That's perfect. Or even a decimal if you wanted to. That's just fine. Now guys, this was a 5-mark question. So if you compare all of this work with like a 3-mark question, which is just finding gradient, it doesn't really add up. But I think when it comes to these more difficult questions, they also don't want to put too many marks on it, because if you don't get it, say this was 8 marks, right? I think they easily could have awarded 8 marks for this. If you don't get it, then you lose all of those 8 marks. Okay, so they rather make these questions count a little bit less, so that if you don't get it, you don't get penalized perfectly. So we're almost there, guys. Almost done marking this question. You see, if we have to mark all 3, it was like the whole hour. Okay, I just want to bring up this picture again because for the last question, it's also quite an interesting one. Let me just make sure that I am thinking of the right thing, not AEC. Okay. I will post this on Classroom after the lesson so you can catch up. You are able to copy all of that down. So this one now they want the area of triangle ABC. Alright, so this triangle here, which is why we highlight on our picture. They want that area. Alright, how do you find the area of the triangle again? Top, base, perpendicular height, right? Is this a perpendicular line? Oh, sorry, a right angle triangle. No, okay. Alright, we said earlier that this is a parallelogram. Now, with the parallelogram, you have a right angle, right? It cuts the whole shape in half. So that means that this triangle is exactly the same as that triangle. Okay? So you could actually, in order to find the area of this triangle, you could actually just calculate the area of this one. Right? It will be exactly the same. Because you got to use it. Right? In a parallelogram, you got diagonal will cut the whole shape in half. So this area is going to be the same as that one. But also, this is the perpendicular height of this triangle. That, right? So this will also be the perpendicular height of this triangle. Okay. Perpendicular height is going to be the same. I think what I did was, we already had this, right? They told us that this was root 80. That was actually given information, but it also calculated this one as root 80. We know that the orders of B are now, what was it, 4/3 and -14/3, I think, right? Is that what we got? So guys, we have the base, right? The base is root 80. We need to calculate the perpendicular height. If I have A and I have B, how can I find the length of the line? How can I find the height? If I have the two coordinates. Okay. Yes. All right, so now we take the perpendicular height of this triangle, it's the same for both of them. All right, the perpendicular height doesn't have to be a side of the triangle. The perpendicular height can literally be from this point of the triangle, for example, perpendicular to that point. That's fine. Okay. We break A to do all sorts of different types of triangles and complex triangles. Okay. So we need to find A, B, that is the perpendicular height, and then the base is 80. Okay. And this again is our question of bringing in like grade 8 words. We haven't done an age, and we haven't done finding the area of a triangle in very long. And now here it isn't a grade 11 question. Okay. Let me just see. Oh, sorry. This one, there we go. Okay, so I said that triangle AEC has a base, AE, that's the top side, which is root 80 units. Okay, that's what they gave us. And the perpendicular height is the same as AD. All right, AD is the perpendicular height of the bottom triangle, so it is also the perpendicular height of the top one, because they are the same triangle. So then I calculated AD just using the coordinates of A and the coordinates of B and the distance formula there. And then from there, I'll use my area of the triangle formula, half base times perpendicular height. And then I just type that in and yeah, got the answer on the top. Okay, so some of these questions are quite hectic, right? Just because if you look at how to work it out, it's not actually that difficult, but often figuring out what you actually have to do is quite fun. Okay, and that will only get easier if you actually practice, which is why I'm saying I'll give you a deadline for the second question. Maybe you just get through it today. I'm not sure how long it would have taken you. All right, but you'll mark that in the same way, step by step. Yeah. Okay. So that is Are you on? Yes, it's good. Okay, so then we would have seen a from. Just put that. Yeah. But yeah, we would see a. Okay, guys. Like I said, I will post that for you on Classroom later. But now we are going on to Trig Graphs, which is the next section. We're going to draw some graphs today. We're going to revise the basic ones, and then I'm going to teach you some new stuff. But we are going to do a lot of the work on the calculator. Okay, so I would like you please to get this calculator out. If you have one, if not, I strongly suggest that you get one of these, the Casio ones. I'm sure that on different calculators you can do the same thing. I just don't know how the other ones work. So it doesn't have to be a silver one, just a Casio scientific calculator. All right, it can be that gray one as well. It doesn't have to be silver. I do have an extra one, but now let me just check. Did I actually pack it this morning? It might be at home. Yeah, I didn't bring it this morning. Sorry. Okay, guys, so you can just make a heading, trig graphs, trigonometric graphs, and I will zoom in now. Okay, that's just the heading there. You can make, normally I would do a box around it, but I'm trying to be fancy now. So don't worry about that. Trigonometric graphs, okay, that's the new heading. I think it is chapter, if you want to write the chapter down, in the textbook, it is chapter 6. Okay, chapter 6, if you want to do that. And then you can write down the basic trig graphs. Okay, standard forms. We're going to do some work here on the side now. I'm going to write some extra little bit. And then we're just going to do a whole bunch of graphs very quickly. Yeah, so I'm going to show you how to use the calculator to help you basically plot all of your points. Not that bad. I don't know. I think you guys did trig graphs like in a big rush last year. Hey, you literally just do sin x, cos x, tan x, and that was it. There was no like 2 sin x or sin x plus 1. Okay. Yes, yeah, you would. Yeah, I remember we ran out of time and you had to just like squeeze a little bit in. Okay, guys, you can just write down there the standard form, and then I'm going to make some notes on the side. So don't write this stuff down yet, the graphs. I might have to move those. So guys, the basic trig graphs are actually just the ones you did last year. Y equals sin x, y equals cos x, y equals tan x. All right, but we can also change those equations. It's not always just going to be sin x, cos x, and tan x. We can put a number in front, and we can put a number at the back. Okay, so I'll tell you now what that means. What those numbers actually do to the graph. Now that's A, all right? In sin and cos. In tan, it's different. Tan is a bit of a different type of graph, all right? So everything that I'm saying about sin and cos is not necessarily true about tan. We probably won't get to tan today, so don't stress about that now. So for sin and cos, right? The A value tells us what we call the amplitude, all right? So I'm just going to write on the side here. A is the amplitude. Can you guys read that thing? Can I do a different color? Am I fine? Fine, okay. A is the amplitude. All right, and amplitude, you probably haven't heard that term unless you do physics. I don't know if you would have done sound waves and stuff yet. All right, in physics you use it as well. Now the amplitude, guys, if we just think back to what a sine graph looks like, right? You remember it starts at 0, then it goes up, it goes back to 0, goes down, and back to 0. Okay, now that x-axis, we will draw it just now. The x-axis is almost like the middle value, right? At the top, it will go up to 1. At the bottom, it will go down to -1. Okay, so the amplitude, a way of calculating it, is if you take your maximum value minus your minimum value and you then divide that by 2. It sounds quite complicated, but it's not actually that complicated when you're looking at the graph. So we'll talk about that now. So guys, your A value actually is going to stretch your graph. Right? You'll see now when you do examples. If your A value is 1, so if we're looking at this one here, right? If the equation, I'll move back up just now. If the equation is y equals sin x, there's actually a 1 in front. Right. But if you have y equals 2 sin x, there's a 2 in front, so it's going to go higher and it's going to go lower. Okay, so the A value is going to stretch the graph. You'll see when we actually draw it. The Q value shifts your graph up or down. Okay, so that is also something new. So this shifts the entire graph. Every single point on the graph shifts up or down. If it's a plus something, it's going to shift up. I think that's quite obvious, right? If it's plus 2, the whole graph is going to shift 2 units up. If it's minus 1, the whole graph is going to shift 1 unit up. Okay, so if it's a positive, a plus Q, it's going to shift up. If it's a minus Q, that number, then it's going to shift down. Now you haven't done that yet, so don't feel stressed if you're a bit confused. Okay, we are going to just draw a couple now and we'll see how it works. Now for today, we are just going to draw these graphs from 0 to 360. Okay, so I would like you just to write down number 1, y equals sin x, and just prepare your axis so long. Okay, just draw your y-axis. I usually just go from, it's actually -3 to 3, all right? But the -3 would be on the arrow and 3 on that arrow, yes? Yeah, there you go. Okay, so just draw your axes quickly so that when we are working on the calculator, we can just put our points on immediately. And on my x-axis, I've just put 90, 180, 270, and 360. Okay, so those are the values that we have to top. Okay, you can get your calculators ready so long if you are done copying that down. Now guys, the important thing with the trig graph is you want to use the calculator, all right? Something that the calculator won't be able to tell you is the period of the graph. Okay, can anyone remember what the period of the sine graph is from last year? It's a very short period of time, so maybe you don't remember. The period of sine and cos is set. It's 360 degrees. Okay, so let's just add that there. Does that sound familiar? Now that I've said it? Okay, the period is 360 degrees. Now guys, later on in this section, we are going to change the period. All right, but this is the normal, the basic period of just a sine graph is 360 degrees. You have to remember that. Sometimes they even ask that as a question. They say, what is the period of this graph? Then you just write 360 degrees. That's a 1 more. Okay. Now the period is 360 degrees. Now guys, I'm not sure if your teachers taught you about step last year. All right, the step is always the period divided by 4. Okay, you have to know that formula as well. In order to use the method on the calculator that I'm going to show you now, you need to know that the step is always the period of the graph divided by 4. Guys, it doesn't matter what that period is. Okay, like I said already, we're going to change the period later on. For now, it's just 360. So the step of this graph is going to be 360 divided by 4, which is 90 degrees. Now guys, the step is how often you have to plot a point. The step, that's the distance between your points. All right, so you can make a little note there. Distance between points. That is why I'm going to plot the point at 0, then again at 90, right? 90 degrees further on. My step is 90, so another 90 degrees further on is 180. Another 90 degrees further on is 270, and then 360. That's actually why we split the axis up into that. Okay, and guys, this is actually coming from the Cartesian plane. If you just think of the Cartesian plane quickly as your quadrants, these are actually the values that you get on the quadrants, right? If you're starting, you're at 0, here you're at 90, 180, 270, 360. Okay, that's where the step is coming from. It's splitting that whole circle into 4 chunks. All right, so the step is the whole period divided by 4. Now we're going to take our calculators, guys. I want you to press the mode button. Now, if you don't have the silver one, if you have a blue or pink or gray one, table is not going to be option 7. It's option, what is it? 3. Okay, for me it's 7. For you guys it will be 3. Please press 3. Okay, whatever the table option is for you, I'm going to press 7. That should come up, f of x. Guys, last year you learned function notation, all right? And you were supposed to learn that f of x just means y. All right. So now what we're going to do is we're literally going to type in the equation of the graph that we have to solve. So we're going to type in sine x. So you're going to go on your calculator, you're going to press the sine button, and now we need to type in an x. Now guys, if you look at this row here, just above your numbers, you see that there's an x above that bracket, right? You need to press alpha and then that button, and it comes up as x. Close your bracket. Just quickly check that you all can find that x, please. So you're literally typing in the equation. When you're done typing that in, you're going to press equals. Now, guys, it's giving you the option to put in another equation. All right, we're just doing one graph for now. So now, to get that g of x away, you just press equals again. Now, where is this graph starting, guys? At 0. So they're asking me, where does your x-axis start? 0. Press 0 equals. Where does it end? 360. Press 3 or type 360. Press equal. What is our step? 90. You type in 90, you press equals. Guys, this table is now giving you the coordinates of all the points that you have to plot. Okay, so it's saying when x is 0, f of x, y is also 0. So the first point that we're going to plot is 0, 0. That's the origin, right? 0, 0. So on your graph, you're going to plot a point at 0. Let's see if I use the big one. There we go. That's the first point. The next point is x is 90 and y is 1. So x is 90, y is 1. That's my next point. The next point, x is 180, y is 0. Now, obviously, my table is finished, so I'm just going to press down, guys, and it does carry on, all right? X is 270, y is negative 1. X 270, y negative 1. And then we still need to go to 360, so we can press down again. X is 360, y is 0. Now all that's left is for you to connect those points. You know what a sine graph should look like. Make a curve, please. Going through all those points. It's not supposed to be a triangle, it has to be a smooth curve. I've never drawn a trig graph on this, so wish me luck. I'm just gonna freeze it and see if I am able to do it. Okay, it's a bit wobbly, but I'll get better. Okay, there we go. There's your graph, guys. Okay, you need to know a couple of things. You need to know what the step is. So that's very important, guys. Step is always the period divided by 2. You need to know where your graph is starting and ending, but they'll give you that in the question. Okay, they'll tell you where your graph must start and where it must end. We'll do a couple of examples where we have different starting and ending text. So there won't always be 0 to 360. You need to know how to type in the equation, and you need to know how to plot points. Okay, so you need to know how to read off that if this is saying x is 360 and y is 0, then on your x-axis at 360 and y-axis at 0, there's a point. Now guys, this is a bit of a mission, but you have to label your points as well with the coordinates. The ones that aren't like labeled here at the axes, you do have to label. Let me just make this a bit thinner. So this one, for example, is going to be 90 degrees and 1. And that one is 270 degrees and negative 1. And they call those turning points. I think that should make sense, right? It's literally where the graph is turning. You have to label those. Okay. For the turning point. But again, this is all on the calculator. The calculator is giving you all of that information. Okay, I just want to help you guys with the next one quickly. All right, because it's about 8 minutes 2 or 7 minutes 2. I'm going to zoom out of it so that you can see the next one. The next one is y equals 2 sine x. All right, so you can just write that down. Y equals 2 sine x, and quickly draw your axis so that can help you with the next one. So then I want you guys to do the next two at home on your own. Okay, so I just want to do another example with you, yeah? Exactly the same process. Yes. The axes look exactly the same as for the first one, guys. Again, the y-axis and the x-axis, they look exactly the same. Just writing here again, the period of a sine graph is 360 degrees. You can fill that in every time, all right? It's not going to change yet. So the step is that period 360 divided by 4. It's always divided by 4, guys, and it comes from the Cartesian plane. Okay, if you forget what you must divide through, how many quadrants are there? 4. Okay, that's where it's coming from. So the step is 90 degrees. So when they ask you on the calculator, what is the step? You need to put in 90. Okay, if you're ready, you can type that into your calculator or not. You're going to use the same process. You're going to do mode. You're going to go into table mode. When they're asking you f of x, you're now going to type in 2 sine x. All right, you type in the equation that you're supposed to be drawing. 2 sine x. Starting is still 0, x is still 360. The step is still 90. Then you're going to press equals, then you're going to plot your point. Okay, just do it quickly. I just want to make sure that you're all okay with this before we go. Two sine x. Okay, guys, do you have a graph yet? Let's take a look. You're going to still write down what you're going to do for the track of yes, that's the one. All right, so now it's still 0, 0, then it's 90 and 2, 180 and 0, 270 and negative 2, and 360 and 0. If you didn't get that, then you must just quickly ask me before you leave to check what's going wrong in the calculator. Now, guys, if we're just comparing these two graphs, do you see what I meant by the A value stretches it? We'll write more notes on it yesterday. But here the A value was 1. Here the A value is 2. It's more stretched. Right? Do you see that? It has the same shape, but it's definitely stretched out. Okay, I would like you to do those two at home, please. Y equals negative sine x. So that's what you're going to type into the calculator. And y equals sine x plus 1. Using the same method, guys, calculator class. Okay.